This video is designed to help you with changing a percent or finding a percent change. Can be used for a lot of applications such as markup and discount or profit and commission kinds of problems. We're going to start with a basic one which says suppose you start at 38 and go up to, let's say, 52. This basically says you have a problem where you have a starting or original number at 38 and you're going to move up a certain amount. Now, I've provided a chart down below that's actually quite useful for organizing these kinds of problems, because it turns out that keeping track of the new number, the original number, and the change that happened, the chart is quite useful for organizing such things. So the definition of percent change, as you can see at the top of this slide, is the amount of change over the original number. In this case, since we started at 38, that would be the original number. So I'm going to fill that into the chart there. We went up to 52, so that's going to be the new number. It's not the change, it's the amount you landed on. So if you had to figure out the change, you would look at that and say you went from 38 up to 52, which means you went up 14. You can fill that in now. What this means is you can write some proportions directly from this chart. So for example, if you were trying to find the percent change, you could now use this chart and use x or n, and I'm going to use different variables since they're different results. If you wanted to find the amount of change, the percent change directly, you could write the proportion x over 100 equals 14 over 38, because this is the change, and I'm going to write a triangle up here because delta, the Greek letter delta, is often used in the math symbol for the symbol of change. And down below is the original amount or number. And on the left side we're looking at the percent, and on the right side we're looking at the number. So x is the percent change if we can solve this proportion. When you solve this proportion, you should get that x is going to be approximately 36.8 and some other details. But if you round that to the nearest tenth, it's going to be roughly 36.8. Now, this proportion that we've written, I'll put that in a box here. This proportion that we've written allows you to compare the change to the original amount. So on the left side, you have the change on top and the original amount as a percent basis. And on the right, you have the change over the original amount on the number basis. So 14 out of 38 is what percent, and that allows you to find the percent change. So this would give you an answer of 36.8% approximately, as we've said. Alternatively, you could have written the original problem as n over 100 equals 52 over 38. And this is going to be the original number on the bottom, the percent on the left again, and the number on the right. But instead of the change up here, we now have the new number, which means that when we solve this, we would get n is approximately 136.8%. Now, once you got 136.8% as the new number on the percent side, that allows you to say, oh, well, we went from 100, which is always the starting percent, up to 136.8, which is the new percent, which means we went up 36.8% to get to the new percent. So In the first case, we did some adding and subtracting to find the results on the number side over there, on the number column. But in the second case, we could do the percent, we could do the adding and subtracting on the percent side, which is usually quite easy because you're always starting at 100% as opposed to some number like 38 or worse, 124.97 or something. So this allows us to solve the problem quite easily using either of these two techniques. On this second slide, we're going to find the amount of change and the new number if we start at some number and I tell you what the percent change is. So using that same definition, first of all, the problem will be, let's start at, let's say 26, and let's go up 21%. So that means we know that the original starting number is 26, and we also know that the change on the percent side is 21, and I'm going to write a little up arrow to remind ourselves that we're going up. And that means if we're going up 21% from 100%, we should land on 121% as our new number. So we've filled in everything we need to do on the percent side, percent column, so we should be able to write one of several proportions on the number side. So if we want to find the change, we can say that 21 over 100 is, and I'm going to put x in here and n up here, I'm going to say x over 26, and what that is the change over the original number. This is the percent side, this is the number side, and that means that we're considering finding the change, so x will be the change. If we solve this proportion, we should get that x is going to be approximately 5.46. What that means is we will be going up 5.46 from 26, which means that we could get that n is therefore 26 plus 5.46 approximately, which gives us approximately 31.46. Alternatively, since we have the new number on the percent side, we could have written the following proportion. 121 over 100 equals n over 26, and that's going to get us the new number directly. And you can check that for yourself. If you solve this proportion, you're going to find that n is 31.46 approximately. So what this shows is that chart kind of helps you organize how you're going to find the new number or the change, but it also helps keep track of these things for you. On this slide, we'll find a decrease so that, let's say we start at 35 and decrease 35 by 60%. What that means is we have a 60% decrease, which means the change is 60 down on the percent side, which means immediately we can write our new number is 40%. So remember, we're starting at 35, so the original number is 35, and now we have a problem that we can write a couple of proportions for again. Let's try to find the new number directly, which means we're going to want to write 40 over 100. Remember, we found the new number, and on the percent side, if you lose 60%, you're at 40%. 40% is left. So our new number is going to be 40% of our original number. So our original number is 35 on the number side and 100, of course, on the percent side. You always start at 100, which means we're going to be finding the new number n And if we solve this proportion, we should get n equals 14. So you're going to find that n is actually exactly equal to 14. And this gets you the answer directly. However, if I said what was the amount of change, we could also solve that. Now that we have an answer of 14, we could find the amount of change by doing 35 minus 14 is 21, and we could have said that that's the change on the number side. But let's calculate that with a proportion just to double check. So we should be able to find the change by doing 60 over 100 from our definition of percent change. And that should equal x over 35. This, of course, is the change, percent side, number side, and original number. And if you solve this proportion, you will get 21 precisely. This final slide gives an example that has to do with a discount or a sale price of a fruit basket, as you can see. So what we need to do is put into our chart what the original price was, and that, of course, is $28.95, which is the price it was originally on sale for. The price it was originally sold for, and that price was reduced to a new number because we want to know how much was saved from the original price of $28.95, which means that the new price, or in this case the sale price, was $24.50. This allows us to then do a proportion to find the new percent, or to find the change in percent. So we could do the subtraction on the dollar side, but that's pretty annoying because these are annoying numbers. So let's do this proportion. N over 100 equals 2450 over 28.95. This is the new number, or the sale price. I'm going to actually write sale price here so that we see what we're talking about. Keep good labels here. The original price. This is the percent side. This is the dollar side. If you solve this proportion, you wind up getting that N is approximately 84.63%, which means that what you found is the new number on the percent side. Now, subtracting that from 100 should tell you what percent you went down, and if you do that subtraction, you should get approximately 15.37%, and that is a decrease. So I'll write an arrow down. This will get you the answer of 15.37 as the percent savings. So again, we did that by doing 100 minus 84.63 gets us this answer directly. So 15.37 is the percent savings, or the percent change as a decrease. Of course, we could have done 28.95 and subtracted 24.50 and gotten that our change was $4.45, in which case we could have done the original proportion as x over 100 equals 445 over 28.95, where we now have the change over the original price, and I'm going to write discount in parentheses after the change because that's how much was saved. That's the amount saved. And if you solve this proportion, you're going to get that x is approximately 15.37. So you get the answer directly. Either way is an acceptable way to do this. One thing that's useful to recognize is that if you fill in the chart completely, you can answer any question that was asked about this problem. In other words, we could ask, what was the sale price on the percent side? Oh, the sale price was 84.63% of the original price. You can ask what the percent change was. You can ask what the amount of change was. You can answer any question. So these charts are useful for organizing that and then looking back to see what you found, and also perhaps if there was a second change or a second price, like if the price went back up after the sale to some price, you could find out what the percent increase was above the sale price. I hope this has been helpful.